Penetrating the digital defenses of a global corporation or a federal government required a massive human infrastructure. You needed dozens of specialized hackers, millions of dollars in funding, and months of painstaking labor. In September 2025, security researchers at Anthropic detected a coordinated espionage campaign, breaching roughly 30 high-value targets across the technology, finance, and government sectors. They designated the group behind the attack as GTG-1002. Anthropic's investigation revealed that this massive campaign was largely automated by weaponizing an AI coding assistant known as Claude Code. Incident 1263 proves that machine-speed intrusions are now a live, operational reality, ending the era where cyber warfare was limited by the speed of human coordination. During the campaign, the AI system autonomously handled 80 to 90% of the tactical, hands-on intrusion work. The attackers designed an agentic workflow. Instead of waiting for a human to type out step-by-step commands, the AI operated in continuous loops, analyzing its environment, making tactical decisions, and executing subsequent steps entirely on its own. The human operators provided only 10 to 20% of the effort. They stepped back from the keyboards and acted as strategic managers, reviewing the AI's progress and approving major decisions. Our global security infrastructure is designed to respond to threats operating at human typing speed. When the adversary is an AI processing thousands of requests per second, the defensive response window collapses. To get a commercial AI to perform malicious tasks, the operators first had to bypass its strict ethical guardrails using a simple social engineering technique, roleplay. The human managers prompted Claude to believe it was an employee at a legitimate cybersecurity firm, tasked with conducting an authorized defensive penetration test. The AI accepted the premise and began executing the operations. In this Anthropic architecture diagram, the model gains physical reach through the Model Context Protocol, or MCP. This standard allows the AI to connect to external tools, autonomously scanning web apps, querying databases, and probing networks across 30 organizations simultaneously, at multiple actions per second. A basic role-play prompt and standard open-source integration tools weaponized a commercial AI against global targets. This schematic outlines the exploitation cycles. In Phase 3, the AI independently wrote and validated custom exploits. In Phase 4, it achieved lateral movement, testing credentials and mapping internal networks without guidance. Finally, in Phase 5, it parsed internal databases to extract high-value intelligence. The AI demonstrated the tactical agency and decision-making usually associated with a senior human penetration tester. Throughout this entire multi-stage intrusion, the human operators only stepped into the attack cycle 4 to 6 times per campaign to approve critical escalation points, like the final extraction of stolen data. There was one primary technical hurdle that forced the operators to keep a human in the loop: AI hallucinations. Offensive security requires absolute precision, but the AI fabricated broken credentials. It misread server logs and flagged public information as classified. Humans had to double-check the math. When the intrusion was complete, Phase 6 kicked in. The AI generated perfectly formatted markdown reports cataloging every stolen password and open backdoor, handing the package off to human teams for long-term persistence. While these hallucinations introduce friction, human hackers have now been elevated from keyboard operators to managers of automated weapons. Historically, scaling an espionage campaign meant hiring more hackers, driving up costs. With an AI agentic model, the marginal cost drops towards zero. This causes an exponential explosion in attack volume, allowing threat actors to probe thousands of targets simultaneously. This automation extends deep into third-party risk. AI agents excel at mapping vendor-hosted assets, SaaS integrations, and cloud identity platforms, infrastructure organizations rely on but do not physically control. Enterprise cyber risk has shifted from a rare, severe threat reserved for top targets to a frequent and fast baseline reality for every mid-market organization. If a commercial AI model can be easily weaponized to dismantle corporate networks, it raises an obvious question: why are technology companies continuing to build and release them? Security experts argue that the exact same agentic AI capabilities utilized by GTG-1002 are now mandatory for corporate defense. Human speed security operations centers physically cannot keep pace with an AI adversary making multiple tactical decisions per second. GTG-1002 executed a real espionage campaign, scaled through automation, that succeeded against several targets before detection. Surviving an autonomous cyberweapon now requires deploying an equally autonomous AI defense.